Hello everyone, I'm Ojas and I'm here to talk about our work Self-Attention Message Passing for Contrastive Few-Shot Learning. This work was done with my colleague Anuj and my supervisor Dr. Hadi. Few-shot classification involves the notion of tasks. Tasks are small classification problems, each with n classes and k examples per class. So if we had n is equal to 2, that means we have 2 classes, and k is 3, that means 3 examples per class. This makes our support set. We have chosen to tackle this problem in an unsupervised manner using contrastive learning. Tasks also consist of a query set upon which the model is evaluated, which means the images are unlabeled. And it looks something like this. Now the problem with standard contrastive learning is that if we pass in these two images, which are from the same cat class, contrastive learning would bring the augmentations close to the source images, but push away the instances away from each other. Ideally, we would want these representations to be close to each other as they are both cats. And this is where our method comes in, which we have coined as SAMP-Transfer. SAMP-Transfer is a combination of a pre-training and fine-tuning method. SAMP stands for Self-Attention Based Message Passing, and it operates on graphs instead of images. The idea is to help the network learn relationships and representations of data. We believe this is more human-like and can help the network look at many instances at once. The first phase, the pre-training phase, is called SAMP-CLR, where we take images that are randomly sampled along with their augmentations and build a graph. Each edge is weighted according to a score, alpha ij, which tells us how similar one node is to the other. The SAMP layer then refines these representations and brings them closer to each other. The contrastive loss aids in doing so. For our classification during the fine-tuning phase, we make use of the prototypical classifier, where the distance between a prototype and a query is measured. A prototype is an average representation of a class. We use the Euclidean distance to measure the distance between the query and the prototype and assign classes based on the distance. One problem that we noticed was that support representations were often clumped up together in one part of the representation space. This led to the prototype being no longer representative of the class and led to a lot of misclassifications. In order to counter this, we came up with an algorithm that uses optimal transport to project the support embeddings into the query domain. This allows for more representative prototypes and increases our classification score. And this only works if representations were learned pretty well by the encoder. And as you can see, our scores on miniImageNet and tieredImageNet. In miniImageNet, we are beating all unsupervised methods that were there previously. We also come close to some of the latest supervised methods. In tieredImageNet, again, we beat some of our competitors in the unsupervised space. So to recap, we introduced SAMPTransfer, which includes SAMP-CLR for pre-training and Optune in the fine-tuning stage that uses optimal transport and prototypical classifiers. We analyze the performance on common benchmarks like miniImageNet, and we showcase SOTA performance. Our code is publicly available on GitHub in the given link, and our paper is also available on arXiv. Thank you.